Okay, so we are going to continue with the sets. So in our today's lesson, we are going to be doing Demogarns Laws. So Demogarns Laws. Basically, under this topic, the main type of question that they ask is for you to prove how to prove these same Demogarns Laws and how to use them. Yes. Okay. So today we are going to focus much on how to prove. So proving Demogarns Laws. So before we go to proving Demogarns Laws, there are some symbols that we're supposed to know, the symbols that we are going to be using in this same lesson. Okay, so for example, like if we have a symbol like that, we know that in mathematics, that symbol means what? A union of a set. So in secondary, we are calling that as a universal set, but it's different from uni. So in uni, that is comprising what? The union of a set. So that is union of a set. Okay. So what other symbol are we going to be talking about? This symbol, the opposite of this. So if you flip that union, we write it like that. The meaning will be what? The intersection of a set. Intersection of a set. Okay. So these are the symbols that we are also going to be talking about. So intersection of a set. Okay. So these are the two main symbols that we're going to be talking about. We also have other symbols like, so this symbol in mathematics under sets, we refer it to as what? A member of a set. Just noting that the elements are part of that set. Member of a set. Member of a set. Okay. And if we write the same symbol and then we put a cross like that, it's denoting that the elements are not part of that set. So this is the what? Opposite of that, member of. But here, this one will be not a member of. So this is a not a member of. Not a member of that set. Not a member of what? Of a set. Okay. So apart from union set, intersection set, member of or not a member of, we are also going to focus much on the what? On the wording. Okay, so the wedding. I'm talking about this wedding. Okay, and I'm not referring to this the wedding that people are getting married. No, it's the wedding. Okay, so in mathematics, we are going to also be interested in the wedding. So whenever we are describing a set inside the brackets, we use the symbols. So inside the brackets, we're going to be using symbols. For example, if we have two sets like A union B, like that. So have you seen under the Morgan's laws that symbol is what inside the brackets? So we have described these sets A and set B using a symbol which is for what? Union set. Okay, so inside the brackets we are going to be denoting or describing the sets using symbols. And then outside the brackets, so if we remove these parentheses here that we are able to see, we are going to denote or describe the set using what? Words. Okay, so the symbol U, so symbol U, the symbol this for union set in words is the same as what? O. Okay, so if we remove the brackets, in replacement of this symbol, we're going to be using that word. For example, A union B, we have described a set in brackets using what? The symbol. So outside the bracket, we're going to say A or what? A or B. Have we seen? There. We have removed the brackets. And we have described this set using the word. Okay, so that's basically what it means. And also for intersection. So intersection set like this. That intersection set, like in wedding, is the same as and. Okay. So after the brackets, we're going to be using and instead of what? This symbol. So for example, if we have A intersection B in brackets, we have described this set using what? The symbol of intersection. Now outside the brackets, we are going to describe this set using what? The words. So the word that is for the word for intersection is what? And. So we're going to say A and B. Okay, so that's basically what we are going to be talking about in this lesson. Also, you have to know what a complement is. So a complement of a set, so a complement in mathematics is just like an apostrophe like that, or some people in some books maybe they can describe it as a symbol like that, small c, or just like a minus. Okay, so these are the symbols of what? Of a complement of a set. So complement of a set basically means that we are removing that set. So the set that is going to contain the complement or the set that is going to have a complement, it means we are not interested in it. But the other sets without a complement. For example, if we have A complement intersection B, we are only going to be interested in the what? In the intersection part of what? Set B and not the A. It means A is not part of this intersection that we are going to be talking about. The intersection here that they are looking for, A is not part of it. That's what it means for a complement. Now, in some books, they can write that as A complement intersection B like that. It is the same things. Okay. Also, you should know that if we have A and then we write it like minus B, so that minus is just denoting that A intersection B complement. Okay, so the minus there is also denoting the what? The complement. So the intersection complement of a Z. Okay, so that's basically about the symbols, the complement, the union, the not a member of, the member of, and the intersection. Yeah. So basically, you have to know all those what symbols. So we're going to be using those symbols to prove Demogan's laws. So what are these same Demogan's laws? How do they look like? Okay, so for example, if we have a question like prove that A union B A union B and then they put brackets complement is equal to the this set which is A complement intersection B complement. We have a question here to say prove that. So this is basically Demogan's laws. You are told to say prove A union B inside the brackets with a complement is equal to our open bracket A complement intersection B complement then close bracket. You are told to prove this Demogan's law. How do you go about it? Okay, so basically here, the main point again that you are supposed to note is that when you are changing the word from member of to not a member of, also the wording changes. So the wording, whenever we are talking about the wording, it is the or and the what and the and part, which is union and intersection. Okay, so let us now prove this law. How are we going to go about it? So basically, if we are given a question like this to prove that Demogan's law, what you do is you are going to prove the left hand side part and then you also prove the right hand side part. So let us start with the left hand side part. So we are going to equate the left hand side part to x or to our letter of our choice. So in mathematics, since we mostly like using the x, so we're going to use x as well here. So we're going to equate the left hand side part to x. So A union B in brackets and then the complement to what? To X. So let us do that. So we have started proving this law now. So we're going to say X is equal to open bracket A union B and then complement. So we're going to replace that equal sign to what? A member of. We are going to say that X is a member of this set. Okay. So what we mean is we're going to say X is a member of A union B, and then we have a what? We have a complement. Now, have we seen? So if we have a complement like X is a member of A union B in bracket and then a complement, it means that so for a complement it will mean that X is not a member of this set A union B without a complement. Okay, so if a set is part of this set with a complement, then it is not going to be part of a set without a complement. You just do the opposite. Okay, a set is in A union B complement, so meaning a set will not be part of what? A union B without a complement. A set can be in both sets for complement and for without a complement. Okay, so let us go to another step now. So we are going to say X. So here we have said that X is not a member of A union B without a complement. So our next step, we are going to just distribute this. X is a member of, rather, X is not a member of, so this, we're going just to multiply with that and with that. Okay, so if we multiply that, and multiplication just simply means we're going to remove the brackets. And I said that if we remove the brackets, we're going to describe this same set using what? The words. Okay, so what words are we going to use there? So we have union. So for union, we know to say we use what? Or. Okay, and for intersection, we use and. So we're going to say if we multiply, X is not a member of A, then we multiply X is not a member of what? B as well. So X is not a member of what? Here, X is not a member of B, like this. Now, what are we going to put there? What are we going to put there? We have seen that there we have what? A symbol union. And we have just removed the brackets. We have done the what? The multiplication. So if we do the multiplication, the symbol also goes, rather, the brackets also goes. We're not going to have brackets here. So the description now of the sets is going to change from the symbol to the what? To the word. So the word that goes with union is O. So there we're going to put O, the word O, O-R. Okay. So X is a member of A, or X is a member of B. We haven't changed anything here. Okay, now from there, we are going to do, if X is a member of A, then it's obvious X is rather, if X is not a member of A, it's obvious that X will be a member of what? Of A complement. Even here for B, we have said that X is not a member of B, so X will be part of B complement. Okay, so here, X is not a member of A, or X is not a member of B. So it means that X here for A will be part of the what? The complement of A. Even here, X will be part of the complement of B. So we are going to say X is a member of A complement, like that. And then we say X is a member of B complement. So now, what are we going to put there? I said changing from member of to not a member of. Also, the wording there changes. So the wording here, we will do what? We will change. So we're going to put a different word there. Now, what different word are we going to put there? So from member of to not a member of, the wording changes. I said we only have two words for union and intersection. So we're going to change the word from or to and. So from or to and. Okay. So there we're going to put what? And. Okay. And. So X is a member of A complement and X is a member of B complement. So if X is a member of A complement and the same X is a member of B complement. So we have seen now that here X is a member of is common. Even here X is a member of is common. So what can we do there? We just factorize. Let us factorize that. So basically what we are going to do is we are going to say X. Okay. So we are going to say we had X is a member of A complement, and X is a member of B complement, like that. So what we are going to do here now is factorize. So if we factorize, we do that. We take which is common here and here. So which one is common? So I've seen that here it is A complement, rather it is X is a member of. Even here it is X is a member of. So those two are common. So we put them outside the brackets. So we say X is a member of, and then open bracket, A complement. Now inside the brackets, what do we use to describe the sets? So we use what? Symbols. So the and there is going to change. So the end is going to change to its symbol, which is what? Intersection. Okay, intersection. So we are going to put that intersection there. And then here we have the B, meaning the B complement there. So X is a member of A complement intersection B complement. So we have proved the left hand side part